Hello, this is Russell Tackett, the Senior Electronic Sales and Application Engineer for HydraForce. This is the third video in the series, Steps to Create a Simple CoDeSys Program. On part one, or the first video, talked about the backbone creation, looking at section 3 of that document that I mentioned, Steps to Create a Simple CoDeSys Program. Video 2 talked about the CoDeSys files that were created offline. This included creating an input file and an output file. That covered sections 4 and 5 of the document. And part 3 that you're on right now will be putting CoDeSys into the controller, downloading the code that was created in part 2 into the controller, and also creating a service tool. This will cover sections 6 and 7 of the document. Okay, so I have opened up HF Impulse, and we're going to use HF Impulse for the initial communication with the controller. So under Communications, I select Communications, and then ECU-0809. On this screen, everything can pretty much be kept the same. You just want to verify which USB to CAN adapter you're using. Right now, I have the CoDeSys CAN hooked up to my controller. Other options are a PCAN USB adapter and an ECAN1. ECAN1 is a wireless unit available from HydraForce. This is not covered in this video. So I am going to select CoDeSys Leaf Light 1. As far as my application or my setup goes, I have an ECU-0809. I have a configuration cable, HydraForce part number 4000306. Connected to that cable, I have two HydraForce coils with Deutsch connectors connected to harness A and B. That's what they're labeled on the 306. I also have an analog input connected to my controller, and then the CAN communication is connected to my CoDeSys, and I have a 12-volt power supply. So if I hit start, the controller or the computer goes out and looks at my CAN network and has found a model number, ECU-0809 serial number, with a CoDeSys ID of 3. You may have noticed that once it found that controller, I hit stop. If I didn't hit stop, it'll just run through all the addresses up to 127 and then stop itself. It really doesn't matter whether you allow it to continue to scan the bus or you stop the scan yourself. Okay, so CoDeSys ID 3. Going back to the CoDeSys code, online communication parameters, I need to verify that the node ID is indeed 3. If it isn't 3, I just highlight it, key in the number I want to, and hit enter. I'm going to go ahead and go back and put 3 in there because that is what we found on our network. Also, CoDeSys CAN under the CAN bus or the CAN card driver. If I hit OK and then come back and say online login, the computer attempts to make communication with the controller. Now, had our program not been downloaded into the controller, which I've already done because it takes a certain amount of time, if it hadn't done that, it would come up and say that the program is different. Do you want to download it? At that point, you could hit OK and download the code, and you would get to the point where we're at right now. One thing I should point out, if you notice in the lower right-hand corner, it is showing that I'm in a running mode. When you first download the code into the controller, it will be labeled like this. So it'll say online local, but the running will not be highlighted. So at that point, you would need to come under the online menu and hit run. Okay, so I'm going to go ahead and cycle power to my controller real quick after the download. Communication error, that's okay since I cycled power. Online, log in. If I come back to my analog input, we can see analog input POU or program. We can see that my analog input coming in has a value of 507. If I vary the analog input, we can see that that number changes from a value of 1021 down to about 5. This is a 10-bit analog to digital converter. That's the resolution of the inputs and outputs for this controller is 10-bit. So that means that the value of the input will be from 0 to 1023. Well, that's not really useful for us. We wanted to look at things as in millivolts. So in part 2 of the video series, we talked about creating this code and creating this ADC to milliampere volt converter, which gives us a millivolt output. So we can see that a value of 523 is an output of 2.55 volts. How this works is, we've got command A and command B. Depending on the voltage of the analog input, we're either going to drive command A or command B. If we are greater than or equal to this value down here, 265, which is our center voltage of the analog input plus a little bit of a deadband. If we are greater than that, then we're going to drive command A. If we are less than our center subtract the deadband center, which is 235, then we're going to drive command B. You'll recall that these parameters of signal center and deadband center, those were set up in the backbone file, which was explained in video 1. If I change my analog input and I go up, we see that my command varies from it varies from 300 up to 1100. That is done because the scale block says I'm going to bring in the analog input and I'm going to convert it from a low of 300 to a maximum of 1100. If I take that back down again and then reduce the voltage, then I start driving command B, which you see on box 21 down here. When lines are active, they come as blue. When they're inactive, they become black. Okay, so if I set a value of command A for 369, I can come over here to my valve outputs, and I can see that the command for command A is 369, which is trying to say that I'm trying to drive a current of about 369 to my coil. This is through the feedback circuit, is coming back through and saying that with our command of 369, it's trying to regulate, so it's bouncing between 368 and 370. This number up here is the command to the coil through a PWM ratio. You see that it's a 227. What that is a duty cycle going to the coil, and then we're reading a feedback current, once again, a raw 10-bit A to D type value of 166, running it through a converter, which is getting us back to our current. Okay, so that is looking at the code online. You can see that there's a lot of information to be read and looked at. There's a lot of different variables to be seen. The next thing I want to do is create a service tool. So for the developer, yes, looking at CoDeSys is fine to be able to determine why the program is functioning the way it is. But if you're sending it out to a customer or a maintenance type person, maybe you don't want them to have access to all of this code, but you want to create a service tool. I'm going to go back to HF Impulse again. This time, to create the service tool, I'm going to come under here and say File, New, ECU-XXXX, ECU-XXXX. I'm going to open the XML file that we created in the video 1 when we created the backbone file. All of these control parameters and monitor parameters have been brought into the program. So if we leave everything checked, our service tool will have all of these items that a service type person can use to either manipulate these values if they want to change a max value or a default value, or to monitor these parameters, the voltage value of an analog input or the amperage going to coil 1 or coil 2. This can all be done through this tool. So once you have selected or deselected the variables that you want, you can export the configuration. I'm going to call it service tool. And hit save. I am now going to close this portion of the converter, and I'm going to open the service tool file that I just selected. You see that it was created today's date. Okay. I will come down, hit communications. I'm going to go ahead and search for that controller again. Sometimes you have to do that every time you start HFM Pulse. I'm going to hit log on. So in the lower right hand corner, it shows that we are online. And now we have information that we can monitor. The control parameters, these are things that we can adjust in the program. And the monitor parameters are things that we can listen to in the program. So we can see that I've got a voltage value on my analog input of 2.81 volts, or a digital value of 281. And it looks like I'm trying to drive the output of my coil 1 at 370 milliamps. Changing the value of the analog input is going to change the current going to the coil. If I come down and go underneath the 2.5, I'm going to start driving coil B. Okay. Other things of interest in the service tool, we can look at active faults if anything has been set as far as an FMI number. We can look at fault history, any of the faults that have happened to the controller since it's been cleared. Communication, we've already covered that screen. And chart recorder. So this allows us to look at other variables if we want to make a graph of them. So I will expand this out. The only 3 variables I have available to me are the ones that we're monitoring on the monitor parameter page. So I could look at the voltage value of the analog input. I could look at my current, and I look at current for coil 1 and coil 2. Notice that the range of these, on auto scaling, the range is plus and minus infinity. So if I change the value of my analog input, which is the red wire or red line, you'll see that the scales continually move around. Sometimes that's a little bit confusing. So it might be easier to unselect auto scaling and put in something there that's a little more reasonable. We know that the value of the analog input is from 0 to 500, so I could make the scale a little bit larger, maybe 550 to 0. The coil currents, we know that they're going to be between 300 and 1100, so we could put a range of 1150 and 250. The same on this one. Okay, now we see that our scales are staying still. When I vary the value of the analog input, I'm seeing different values for both a coil 2 or a coil 1. Okay, so that is the explanation of the service tool, which is also documented in section 7 of the procedure steps to create a simple CoDeSys program. This concludes the video series. This concludes video 3 and the video series and how to create a simple CoDeSys program. As a review, there are 3 videos. The first one talks about the backbone creation and all the things that need to be done there. Section 3 of the document. Part 2 of the video, or the second video, talks about creating the CoDeSys files offline, both creating an input file and an output file, and this is documented in sections 4 and 5. Part 3 that we've just concluded is CoDeSys Online, looking at downloading the code and creating a service tool, which is represented or documented in sections 6 and 7 of the document. This concludes the video series. Good luck with your creation of CoDeSys programming. If you have questions, please reach out to HydraForce and we would be happy to answer them for you. Thank you.